Hello, so today we're doing the ACT science section, and my biggest tip on this is go as fast as you can. It is a race. It is brutal. Go as fast as you can without losing accuracy. Try to at least, and you might survive. Good luck. Alright, so all kidding aside, what I mean by go as fast as you can is in this section you have 35 minutes for 40 questions. Not the best timing, but again, we all know that the ACT doesn't always give you the best timing. So you have 7 sections. I believe it's always 7 sections for every test. 7 sections on the ACT science. 7 sections on the ACT science section. That's confusing. 7 passages on the ACT science section. Every passage will give you a graph or graphs, mostly graphs, and a little passage to go with it. And I think there's one passage where you're reading different like hypotheses and stuff like that, and then you compare them, but mostly you're looking at graphs. And because you have like such short time, you do not have time to read the little passage at the top of the graph. Let me show you what I mean. First passage. You do not have time to read this thing. No, ma'am, no, sir, you do not. You need to go straight to the questions. Okay, according to figure 1, okay, my first thing I do is just go find figure 1. Okay, here's figure 1. The mass of cheese remaining at 4 hours was closest to which of the following values? All right, I go 4 hours. Cheese is going to be the white. Right here, it's about, let's say like 185-ish. And I got 185. Bam. Right there. That's all I needed. So I did not need to read any of this little thing. And you'll always find, let me show you the next passage. It also has this. Now the student, oops, what happened? Sorry. Now the student parts, you will need to read that. But still, like, read the question first, because it will make you refer to it anyway. So you'll know that you're gonna have to read it. But like this little part up here, you do not need to read it. And the only exception is if you read a question, and this will be rare, but if you read a question, and you're like, I can't find it in the graphs anywhere, I don't know what to do, then go back and read it, and then you might find your answer here. And I do have one exception to that. If you follow the tip I just told you, and you read the questions first and only look at the graphs and not the passage unless you need to, and it's not working for you, like I need to understand what's going on in the graph before I answer the question. Like it doesn't make sense, and when I read the passage it makes more sense, then do that. But please try to not read it, practice it a couple of times and see if it works, because it helped me tremendously. At first I was like, there's no way I have time to read this and read the question and then look at the graph and then look at another graph and then compare the graphs, and a little too much. So that is a really big tip I have. But I did find someone tell me that they needed to read it. But for the most part, you really don't need to read it. Barely. You'll find like 1 or 2 questions where you need to refer back to the passage, and that's when you'll need to do that. But you'll get through most of the passages without ever giving a second thought to the beginning introductory thing. So I also wanted to mention how you can find the ACT, how to find good practice tests. So the SAT is easy, so just search up on the Google SAT full-length practice test, and probably the first thing that'll show up is the practice tests that are released by College Board itself. Those are your best bet because they're released by the same company that makes the test itself, and so you'll get real test-like questions. For the ACT though, I wanted to show you how to do that. But before I do, let me mention any other websites other than the ACT or SAT themselves. I highly do not recommend using them because sometimes they'll make the questions harder than they are to because they're like they'll make the questions harder than you'll ever find on a real exam, or it'll be different, or they'll use big vocabulary, or on the test there isn't big vocabulary, blah blah blah. It's not gonna be the same because I've tried. Maybe you'll find a good one. If you do, you know, let me know. But what I have found is using the ones that are released by the ACT and the SAT themselves, and the College Board themselves are the best resources to use. And if you're worried, like you might be thinking, well, okay, if that's like my only option, I'm not gonna have enough practice things. No, they released a lot. I think there's like 9 or 10 like full-length practice exams with the answer sheets for you to check. And the SAT also has answer explanations. So I highly recommend that. So now let me show you how to get to the ACT. It's pretty similar to the SAT, except it's not on the ACT website itself, but you can get to it. Jump on Google ACT full-length practice test. The very first thing that comes up is from the Prep Scholar, and you might be able to find this in another link too, but it's just the first thing that pops up, and it works. So you go and you have all these options to choose from. Also, and so like you click on it and then you'll find the whole thing, and then at the end they'll even give you an answer sheet to print out if you want, and you have the answers and everything's cool. Also, you can find at least at my high school, they would have like a whole the full booklet of this available, so you can do it on paper too if you prefer to kind of get used to doing it on paper like you will do on the actual exam setting. But yeah, this is how you get to it. Alright, so another thing about the ACT science section is it's the last section of the ACT. So while you're taking the exam, you might be tired, your brain power might be dying down, but grind through it, because like I said, you will have to go very fast in order to make it on time. 35 minutes for 40 questions is not a lot of time, and you don't want to make a careless error like looking at the wrong grid of the graph, and that's why you lost a few points. So just wanted to keep that in mind, that even if you're tired, don't just like give out, grind through it, and then after that get ice cream and celebrate. Alright, so timing. You have 35 minutes for 7 passages. That gives you about 5 minutes per passage. Again, not a lot of time. What I used to do actually, like towards the end when I've practiced it a lot and I kind of got the hang of it, was kind of do it in 4 minutes, because some passages I knew, like usually I think they say like the chemistry one is usually the hardest, but I try to save myself time for that one passage that I knew I was gonna get stuck on. There's always a passage that I would go slower than on other passages. So try to keep yourself in the beginning for 5 minutes, and if you feel like you're spending more time on one passage than you do on the others, then try to speed up the other ones and give the one that needs more time the time that you took away from the other ones. Also, just because it says the science section, that does not mean you need to know real science to answer these questions. It's great, I know, but seriously though, if you have 0 science background, you can get a perfect score on this section of the exam. It's all basically graph questions. Almost all the questions are basically asking you, what does this graph say? You just need to know how to read the graphs fast. That's literally the only thing that you need to know, and maybe read a few little sentences about something and answer the questions about that. But yeah, like there is very rarely will they put in one question in the test that requires real scientific knowledge, like what is photosynthesis? But okay, it's not that simple, but they're very basic, maybe biology questions, and they're not asking you to take AP chemistry to be able to answer those. So don't blame your science knowledge on not being able to get through this exam. I really feel like it's mostly just test taking strategies to get through this section especially. You don't need to have any knowledge, but the biggest thing is practice, practice, practice. All right, a little bit of disclaimer on what I just said. Even though you do not need real science knowledge to answer these questions, they will throw at you big science words. Now, do you need to know what those mean? No, but that does freak some people out, and I'm pretty sure it freaked me out at first. I was like, I don't know what B. Germanica means. I can't answer this question. No, if you really want to know, you can go to the passage in the introduction, and they explain everything. But basically, don't let that scare you. They're just like, if you replace it with an X and a Y, like the species X and species Y, you'll probably still be able to answer the question. They're just using big titles that they have probably labeled in the tables, and sometimes you will have to go back to read the passage, like I said, to understand something, but most of the time, no. And a lot of the times they will use big words that you don't really need to know in order to answer the question, and also use kind of what's the word for it, context clues to understand it as well. But yeah, just don't let that scare you, and I'm sure after practicing it a couple of times, you will get the hang of like how they're using the words, and it's just a big noun, really. Don't let that scare you. Another thing that you'll find yourself doing in the science section is making some basic calculations. And the thing about this is these are not meant to be hard. You're not meant to do super long division and all that. But keep in mind that sometimes it will look hard and you just need to estimate. So let me show you. Asking me the difference between this little gray bar and this black bar. And so I wasn't gonna go over here and be like, oh, that looks like 168. Like, no, it's 170 minus around 110. 170 minus 110 is going to be 60. So I went to my answer choices, and I had something that gave me 55 and 95. Which one is closer to 60? The 55. That's going to be my answer. I don't need to scrutinize the graph and draw a line with my paper ruler and do all that. You just guesstimate and you'll find an answer. Alright, I just want to point out something. This may be common sense, but I'm just going to point it out anyway. So this question is asking me based on student 1's explanation. Here's student 1's explanation. It's just a couple of sentences. And then it asked me a question about that. I'm only gonna read student 1's explanation. I'm not gonna go over here and then see what the other student says. I'm only gonna read student 1. And then the next question is asking me about student 3's explanation. I'm just gonna skip over student 2 and look at student 3. I'm not gonna look at anything else. Do not confuse yourself by looking at things that they did not ask you to look at, or things that you do not absolutely need to answer the question. Do not confuse yourself. Just look at what you need to answer the question. For this question, for example, I'm just gonna let you look at it real quick. For this question, I just need to read student 1's explanation and then look at the graph to help me answer the question. Didn't read this little part. I didn't read any of the other students' explanations. I didn't read what the teacher asked them to do or whatever is over here, or any of the note. I just looked at what I needed to and then went on with my life. Another tip that I have, this will help you sometimes, not always, but if you're reading a question, like read number 9, for example, pause the video and go ahead and read it. So I'm assuming you've had a go at it. So number 9 is asking me if sample A is going to be a solid or a liquid. Like my first thought reading this is like, well, how am I supposed to figure that out? And then once I take a glance at the answer choices, I see a melting point. So I'm supposed to be looking for melting point. So I go back up here and I'm searching for the word melting point, and here it is. And then sample A is 126, and then I'll go and look for my answer. But basically what I'm trying to say is sometimes just taking a glance at the answer tells you how to approach the question. Not always, but this will sometimes help if you're staring at a question and you're like, well, how am I supposed to know? Something else that I wanted to throw out there that some people have a myth of is that answer choices, all of the above or none of the above, are not legitimate and they will always be wrong. Now that might be true in your class, you know, sometimes the teacher will say never pick all of the above because that will always be wrong. But on the on the SAT and the ACT, those are legitimate answer choices that are sometimes correct. So don't just throw those out the window because you think that they will never be right, because they are sometimes right. So just wanted to throw that out there. Alright, read question 13 real quick. Pause the video and read it. So I'm assuming you've read it. Again, just reminding you to not let big words or things that you've never heard of or information that you're not using scare you. For example, it says 1 atmosphere of pressure and 1 atmosphere, again it repeats it down here. You did not need to know that ATM is atmosphere. You did not need to know anything about the pressure at all to answer this question. So just don't let that throw you off. Like I said in another video, sometimes both the ACT and the SAT will put in unnecessary information to either try to confuse you or try to keep out arguments. Like some people would be like, well, if the pressures were different, maybe the density would change or blah, blah, blah. I don't know what their argument would be. But sometimes they put that in there just for that, or to just give you random information that you really don't need. So just throwing that out there, and especially since it's 1 ATM and 1 ATM down here, if they're the same, then it's not going to change your answer. So again, if you're not using the information, if you're not using every piece of information they're giving you, don't freak out. Also, just because the passages are ordered the way that they're in, that does not mean that you have to answer them in the way that they're ordered. So if, for example, like I mentioned before, a lot of the times the chemistry passage will be harder for students than other passages for some students, and so if you find yourself that you're one of those people, then skip the chemistry passage for last, you know. Give yourself maybe more time to do it, or focus on give yourself more time to do it by taking away a little bit of time with the other ones if you can. Or if you can't, then at least you have those 5 minutes and you're losing time on the passage that you probably would have gotten questions wrong on anyway. So it's a win-win situation. So if there's a certain passage, it doesn't have to be chemistry, like anything. If there's a certain type of passage that you find yourself you're struggling with more, it's okay to skip it and go on and then go back to it. Just remember to keep 5 minutes at the end for it. Alright, so I wanted to give you a tip about reading graphs. For example, question 15 says how many temperatures were tested in experiment 1 and how many temperatures were tested in experiment 2. Let's look at experiment 2, for example. So I'm looking at figure 2 with an experiment 2. Well, figure 2 is experiment 2. But basically, when I looked, I'm not gonna count the temperatures down here. I'm not gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not gonna look at how many the measurings are. If I'm trying to find how many temperatures they tested, I'm gonna look at how many dots there are on the graph. So like I see 1, 2, 3, 4, 5. So they tested at 5 temperatures, because every dot implies that it's an exact measurement, and all the lines in between were them just connecting the dots and therefore the measurements that they tested at. So yeah, that's just what I wanted to say. Like the dots, that's what they signify. They signify that that's what they tested exactly. And the lines are connecting those dots. So whenever they ask you a question like that, count the dots or the squares or the triangles or whatever, instead of counting the measurements down here on the y-axis, or sorry, x-axis. Something else that I wanted to mention is that if you're running out of time, you do not have to keep looking back at the graph and answering every single question. For example, in this passage, I find myself running out of time and my 5 minutes are almost over and I'm not almost done with the questions in the passage. So I was reading question 16, for example, and based on answering the questions that I've answered before, and I've already seen the graphs before a few times because I kept referring back to them, I didn't need to look back at the graph to answer this question. I just, based on what I remembered and process of elimination, I answered the question. So of course it's usually better to look at the graphs again, but you don't always need to do that, and especially if you're running out of time, it's okay if you try to use your memory instead. Now, if you can't remember, of course, go back. You don't want to miss the question. But I didn't even think of not looking at the graph until I was running out of time. So I just wanted to throw that out there, that that is an option. And after answering a few questions and referring back to the graph a few times, you might already have a lot of the graph's information in your head. Or not the graph's information, but like the axes and stuff, that you don't need to refer back to it to answer a question, and that will save you time. So again, don't do it if you don't remember right off the top of your head, but just think of that, just put that in your mind as an option, because I didn't even think of that as an option until I had to when I would run out of time. Okay, so based on where you are in your high school career, you may or may not understand what this question is asking. And to be honest, I don't quite remember if they ask this often or not, but I'm gonna go through it anyway. Read question 19 real quick, pause the video and read it, and then come back. So I'm assuming you've read it. Question 19 is asking about moles. So what in the world are moles? They're asking you to look at the equation, and the equation is given to you right here in the passage. Like everything else that you need to answer the questions are, and they'll always be either in the passage or in the graphs. So moles are just a little number in front of the compound or the element or whatever it is. And of course, when you get to your chemistry class, they'll explain this more in depth, maybe not, but for now that's all you need to know. It's just the number that's in front of it right there. So just by knowing that, you'll be able to answer the question, and who knows, maybe you've even figured it out before I told you this, but just wanted to make sure you knew it in case it comes up more than once. So something that you may want to consider if you choose to organize your passages in order of what you'll do first and last, in terms of like what is the easiest and hardest for you. I don't know if it's just me, but just wanted to like throw it out there in case it's like that for other people as well. I find that the chemistry passage is usually harder and one of the hardest ones, and the physics passage is one of the easiest ones. I get through that one like that, and I have a feeling it's because physics, like the actual physics class, is generally hard, that they intentionally try to make the physics passage easier. But yeah, just wanted to throw that out there just for you like to be cognizant of, in case that's the same for you. So okay, so this might sound extremely common sense, but just wanted to make sure all the tips are out there. On question 24, they're asking you to find which two voltages are always opposite in polarity. Do not use process of elimination and look at every answer choice and then go back at the graphs and check for it, and then go back and then cross it out and then do that and then do that. That's way too much time that you definitely do not have for questions like these that you can figure out yourself. Go back and look at the graphs all together and see which ones were opposite in polarity. In this example, it's going to be VL and VC. So you go back and you choose the answer choice with VL and VC, and then you're done. And so I know this might be very common sense, but you know, it's a tips video, so why not? Alright, another thing to keep in mind when reading graphs is if you're looking, for example, the eye where it's negative, you might think, oh, well, it's anywhere going to be from 10 to 20. And then the answer choices, they might have something like 10 and then 14. And you're like, well, wait, those are both in there. But remember that 10 is at 0, so that does not count. So the correct answer choice would be 14. You may not struggle with this, but I remember in the beginning, and still now sometimes I'll look at it and I'm like, wait, they're both right, and then I have to remind myself that one of them could be 0, or yeah, one of them is 0, so then only one of them is correct. Okay, so I almost always find a question that asks me what the control of the experiment was, and in those cases you will almost always have to go back and read the introduction of the passage, or other wording in the passage, and those are going to be one of the rare cases that you do actually have to read something and you can't go off of the graphs alone. So if you find a question that's asking you in some way, shape, or form what the control of the experiment was, then you know that you'll probably have to go back and read something in the passage. Another example of not letting sciencey stuff scare you when you really don't even need to know it. So this is scientific notation, the times 10 to the negative 9. And I don't remember if I ever actually needed to know that on the science section. Maybe there was, maybe there were questions before about that. I don't honestly remember. But example for this question, if you don't know scientific notation, if you haven't been taught that yet, you really don't need to know to answer this question, especially since if they're all the same. So if you find something that you don't know, and they're all the same for the things that you're trying to compare, just ignore it. If they're all the same, it's not going to make a difference. 10 times 10 and 20 times 10. 20 times 10 is still going to be greater, even if you don't know what times 10 means. Now I'm oversimplifying this. I know it's times 10 to the negative 9, but just giving you an example that you don't always need to understand everything in the problem in order to solve it. Alright, so pause the video and look at question 32 real quick. So I'm assuming you've read it. So when I read this question, at the end of the question, I was like, come again? So I didn't really understand what the question was asking for until I took a glance at the answer choices. So this is, again, another example of the answer choices helping you determine how you're supposed to go about answering the question, and especially since it's asking me to complete the sentence for them, basically, and I would have had no idea what they were asking for unless I read the answer choices. I really don't know if there's any other way about doing this specific problem, to be honest. Maybe there is, but for me, I had to read the answer choices, take a glance at it at least, to kind of figure out what I'm supposed to do. So if you're stuck on a question and you have no idea what they're asking you, try taking a glance at the answer choices instead of rereading the question and then finding out that you wasted your time, and if you had just took a glance, then you would have understood what they were asking you to do. So just another reminder. Okay, so another tip that I have for you is when you go to the actual exam, make sure that you have a digital, not analog watch. It's gonna really, really help you to know the exact minutes that you have left, and also you may be able to use it to figure out how many seconds you have left. So say you're supposed to finish at 9:15, right now it's 9:14. Usually you start bubbling in all the answers that you didn't finish yet, if you didn't finish any. But what if you knew that you had a whole 45 seconds left? That's enough time for you to look at a whole other question, depending on the section of the exam that you're in. Now, you may not be able to do this if you hadn't looked at your watch the exact second that it started at when they started timing the exam, but you could do that if you were cognizant of it and you looked at like your exam on your watch started at like 8 and 5 seconds, and then you know it will end at, look, if it's an hour, then 9 and 5 seconds, so you'll know exactly how many seconds you have left. Now, you don't have to do this. I know this is really like precise timing yourself, but you could do that if you're like me and some of the exams you need every single second, and you're willing to put in the extra brain power to time yourself. But other than that, it still helps you to know the exact minute that you're in.